Day 38. This will be a short one, but let's begin with time series analysis of past rates of return. Time series versus scenario analysis. Um, one sec. In a forward-looking scenario analysis, we determine a set of relevant scenarios and associated investment rates of return, assign probabilities to each, and conclude by computing the risk premium reward and the standard deviation risk of the proposed investment. In contrast, asset returns histories come in the form of time series of realized returns that do not explicitly provide investors original assessments of the probabilities of those returns. We observe only dates and associated HPRs. We must infer from this limited data the probability distributions from which these returns might have been drawn, or at least the expected return and standard deviation, expected returns, and the arithmetic average. When we use the historical data, we treat each observation as an equally likely scenario. So if there are n observations, we substitute equal probabilities of 1 by n for each PS in equation 5.11. The expected return ER is then estimated by the arithmetic average of the sample dates return. ER equals to sigma of PS into RS, which is equal to 1 by n of returns. So arithmetic average of historical rates returns is equal to the expected return. Example 5.6 illustrates the logic for the wide use of arithmetic average in investments. If the time series of historical returns fairly represents the true underlying probability distribution, then the arithmetic average return from a historical period provides a forecast of the investment's expected future HPR. So yeah, example 5.6 is we don't have to do that because we don't have the spreadsheet right now. Let's move on to the geometric time weighted average return. The arithmetic average provides an unbiased estimate of the expected future return. But what does the time series tell us about the actual performance of a portfolio over the past sample period? Let's continue. Example 5.6. Using its very short sample period, just to illustrate, we will present results for meaningful sample periods later in the chapter. Column F in spreadsheet 5.2 shows the investor's wealth index from investing $1 in an S&P 500 index fund at the beginning of the first year. Wealth in each year increases by the gross return, that is by the multiple 1 plus HPR shown in column E. The wealth index is the cumulative value of $1 invested at the beginning of the sample period. The value of the wealth index at the end of the fifth year, $1.0275, is the terminal value of the $1 investment, which implies a 5-year holding period return of 2.75%. An intuitive measure of performance over the sample period is a fixed annual HPR that would compound over the period to the same terminal value obtained from the sequence of actual returns in the time series. Denote this by G. So that terminal value equals to so on and so forth. Practitioners call G the time weighted as opposed to dollar weighted average return to emphasize. I emphasize that each past return receives an equal weight in the process of averaging. This distinction is important because investment managers often experience significant changes in funds under management as investors purchase or redeem shares. Rates of return obtained during periods when the fund is large and have a greater impact on the final value than rates obtained when the fund is small. We discussed this distinction in chapter 24 on portfolio performance evaluation. Notice that the geometric average and return in spreadsheet 5.2 0.54%. Oh, here's the spreadsheet, by the way. Let me see this. 0.54% here. Is less than the arithmetic average, 2.1%. The greater the volatility in rates of return, the greater the discrepancy between arithmetic and geometric averages. If returns come from a normal distribution, the expected difference is exactly half the variance of the distribution. That is, expected return of geometric average is equal to expected return of arithmetic average minus half of variance. Warning. When returns are approximately normal, 5.15, it would be a good approximation. The discrepancy between the geometric and arithmetic averages arises from the asymmetric effect of positive and negative rates of return on the terminal value of the portfolio. She's this effect. Okay. Suppose you have rate of return minus 20% year 1 and 20% year 2. The arithmetic average is 0. Here, each dollar invested for 2 years will grow to only 0.8 times 1.2, $90.96, less than the dollar you started with, implying a negative geometric average return. Your positive HPR in year 2 is applied to smaller investment base than the negative HPR incurred in year 1. To break even after losing 20% in year 1, you would have needed a rate of return of 25% in year 2. Now suppose that the order okay, I'm not really reading all this stuff. Okay, concept check 5.4. You invest $1 million at the beginning of 2020 S&P stock index fund. If the rate of return 2020 minus 40%, what rate of return 2021 will be necessary for the portfolio to recover to its original value? So you lost what, 400,000 basically. So you need to gain 400,000 again. So that would be 50%. Because 400,000 of 800,000 is 50%. So that's a 50% rate of return. That's a pretty simple question. Variance and standard deviation. When thinking about risk, we are interested in the likelihood of deviations of actual outcomes from the expected return. Because we cannot directly observe expectations, we calculate variance by averaging squared deviations from our estimate of the expected return. The arithmetic average R bar adapting equation 5.12 for historic data. We again use equal probabilities for each observation. Use a sample average in place of the unobservable ER. No, सिर्फ लास्ट वीक मैंने दो मिस करी थी एंड अभी मैं तीन मिस हो गई है बेसिकली. Variance equals to expected value of square deviations. Square deviation. Okay. Expected value of P and could estimate variance as deviation. Yeah, you know what? I'm just gonna call it right there because my head's aching a lot. So I'll continue doing this tomorrow when I'm feeling a little bit better. But yeah, that's fine. We did like what, 1 page, a couple of pages. So that's something. 3 pages, yeah. 3.5. Anyways, thanks.